Hi everyone, welcome back to Mr. Edmond's channel. So today I'll start with P3 differentiation. My first topic is the chain rule. So the chain rule, by the end of this lesson, I'll go through, you should be able to do the chain rule mentally, but I'm going to go through the steps, how we come to this chain rule, and then later I'll conclude how you can do it mentally. Let us dive into the lesson. If you see this kind of question in P1 or P2, you may think about opening the brackets. But now what happens what if it is negative? What happens what if it is a fraction? Now what you're going to do in the chain rule, you're going to think about another variable. So here what I'll say that let my u and its second variable be 2x squared plus 4, such that y is a function of u, so it is u to the power of 2. Then I'll get the u, the derivative of u respect to x, which is going to be 4x. And then I'll get the derivative of y with respect to u, which is going to be 2u. From the chain rule, my dy dx is going to be dy du multiplied by du dx. So that means my dy dx, the derivative of the function, is going to be dy du, which is 2u, multiplied by du dx, which is 4x. So your final answer here is 2 times 4, which is 8x. And then what's your u? Your u is this function here. So your answer is 2x squared plus 4. That's your final answer. Let us try to see this one here. Now for this, our u still is going to be the 2x squared plus 4. And then that means our y is u to the power of negative 4. We go through the same process. So du dx is going to be 4x, and then dy du is going to be negative 4 u to the power of negative what? 5. Join them together, so your dy dx is going to be equal to, so dy du multiplied by du dx. So what you have, dy du, so you have negative 4 u to the power negative 5 multiplied by 4 what? 4x. This is negative. So your final answer, your derivative here, is going to be minus 16x, and then the u, which is 2x squared plus 4 to the power of negative what? Negative 5. That's your derivative. Let us have another example here. Now, for another example, if I have this question here, I'll do exactly the same thing. My u will be the one in the bracket, which is x cubed plus square root of x. And then it means that my y is u to the power of 4. So what we have, du, this is not dy, du dx is going to be 3x squared plus the derivative of this. Remember, this is just x to the power of a half. So the derivative is going to be a half, x power of what? Negative a half. And then you have your dy du as 4u to the power of what? 3. Join it together, so you have your dy dx as equal to dy du multiplied by du dx. So your answer here is dy du, which is 4u to the power 3 multiplied by dy dx, which is all of this. I mean du dx, which is 3x squared plus a half x power of negative what? Negative a half. So your final answer, your dy dx, is 4 into, multiplied by all of this, x squared, this x power negative a half, multiplied by u, whereby your u is x cubed plus square root of what? Of x to the power of what? To the power of 3. That's your dy dx. Now what I want you to see, I want you to see the pattern of the answer. I want you to see the pattern of the answer so you can be able to do this mentally. Now, when you look at the pattern of the answer, you see that the logic here is that my answer here, look at this final thing over here. My answer here is the derivative of this function inside, the derivative of this function, which is 4. Then for x, then this power here comes down, which is 2. And then I have the function itself left as u, which is over here. That's my answer. Look at this one. The derivative of this function inside, which is going to be exactly, which is going to be 4x. So you can see it is the 4x over here. The negative 4 comes down, and then it loses 1 power because you are finding the derivative. It loses 1 power to negative what? to negative 5. That means if I have this, we can do this mentally and say what's our derivative here? Our derivative here is the derivative of the inside, which is going to be 4x, multiplied by the a half comes down. And then this function here loses one power and becomes what? And becomes 2x plus 4 to the power of negative what? Negative a half. So your answer for this is what the derivative is 4x times a half and then 2x squared plus 4 to the power of negative what? Negative a half. This is the shortcut, but still you have to be able to know how to do all of this. Now, let us see another example and see what if my function, say y equals, say, x cubed plus 2x squared, power of negative maybe 90. That means my derivative, dy dx, if you're doing it mentally, I'll get the derivative of the inside, which is 3x squared plus 4x. All right. And then the power comes down, multiplied by negative 90. Multiplied by, this function now loses one power because you're getting the derivative of that function, 2x squared, to the power of negative 91. So here you're doing the chain rule mentally, but knowing how everything turns out to be this is very important. That's the first step I did. Plus 4x into x cubed plus 2x squared to the power of negative what? Negative 90. That's the chain rule. Now you can do it mentally. Next one, we go to exponential. The next derivative is the derivative of exponential function. Now what is known, or what you should know, is that the derivative of ex remains ex. This is one function that remains the same when you differentiate it. Now, how do we then get the derivative of e to the power 4x? How do we again get the derivative of, say, maybe 4 e to the power 2x plus 3? Now, we are going to use the same concept of the chain rule to understand this. Now, remember there's a shortcut for this, but understanding it is very, very, very important. We are going to let our u be 4x such that your y is e to the power of what? To the power of u. So it means that your du dx is equal to 4 and your dy du is equal to e to the power of u, because the derivative of the exponential remains the same. So that means when you use your chain rule, you know that dy dx is equal to dy du multiplied by du dx. You see that your answer is going to be dy du, which is e to the power of u, multiplied by du dx, which is 4. So your final answer here is 4 e to the power of 4x, because this is the u here, what you're putting over there. That's your derivative. Now, even this one here, you're going to do the same thing. And this is a constant, so don't worry about that. So you let your u be 2x plus what? 2x plus 3. And that means your y is equal to 4 e to the power of what? E to the power of what? To the power of u. That means your du dx is just 2. And then your dy du is going to be, is just a constant, so just 4 e to the power of u, because the derivative of u, e to the power of u, is e to the power of u, and this is the constant, just multiplied by 4. That means your dy dx is going to be equal to dy du multiplied by du dx. So what is your dy du? Your dy du, you know, it is 4e to the power of u multiplied by dy dx, multiplied by this du dx, not dy dx, multiplied by du dx, which is 2. So your final answer is 8 e to the power of u. What's u? U is 2x plus what? Plus 3. That's your derivative. Now, take note of the answer. There's a shortcut here, but I don't give you the shortcut at this point. I will give you the final shortcut. Okay. The next one here, we do exactly the same thing. Our u is equal to x squared. That means what we have here is our y is equal to e to the power of what? Of u. So the derivative du dx is going to be equal to 2x. And then dy du is still e of u. So when you use your chain rule, dy dx as equal to dy du multiplied by du dx. What do you have here? You have dy du, your dy du, which is e to the power of u multiplied by du dx, which is 2 what? Which is 2x. So your answer is going to be 2x e to the power of x squared. That's your derivative. I'll do one more before I go to the shortcut. So here we have our u as equal to x squared. We have x squared minus 2x. You can see that I'm always using the power as my u, and y is equal to 4 e to the power of what? E to the power of u. So we have our du dx as equal to what? As equal to 2x minus 2, and our dy du as equal to 4e of u, because for the constant, just a constant, the derivative of e is e. Then you join them together. So dy dx is equal to dy du multiplied by du dx. So I have the y du, which is 4e power of u, times du dx, which is 2x minus 2. That means you can write your answer as, I can open the bracket or I can just leave them in the brackets. Whichever way I do it, it is okay. E to the power of u, which is x squared minus 2x. Now let us try to see the shortcut here so that we can come up with the formula. Let us see the shortcut here so that we can come up with the formula. Okay, now look at the answer for this. The answer for this, look at the final answer here. Now the final answer, you can see that this is 4x. What's the derivative of 4x? The derivative of 4x is 4 over there. And then this is exactly the original function that was given. What about here? This 4 is a constant. So look at 4 as a constant just as outside here. 4 is just a constant. And then look at the derivative of the function on the top, which is just 2x. It appears over here. And then you have the function itself, the original function itself, which is e of that. That means what we have over here, we have our 4, which is a constant, and we have the derivative of the function on the top, which is 2, and then multiplied by the function itself, which is 2 e of that. All right, that's the shortcut. So you have the 4, just a constant, but you have the derivative of the function up there, and then multiplied by the function itself. Let us see if it's the same logic here. If it's the same logic here. Is it the same logic? Yes. What's the derivative of this function on the top? X squared. Derivative of x squared is what? Is 2x. And then you multiply it by the same function. This is the easiest differentiation, the same function, which is e of ex squared. What about over here? Look at the 4 as a constant. The 4 is a constant there. What's the derivative of that function? The derivative of that function is 2x minus 2, which is this one over here. And then multiply by the function itself, which is the function itself. That means we can make a conclusion and say, if you're looking for any derivative of a function in terms of exponential, your answer is going to be the derivative of the function on the top, that's the power of the e on the top, multiplied by the function itself. That means if I have, say, y is equal to e to the power, say maybe 2x cubed minus x squared, the derivative is something very simple here. Get the derivative of the function on the top, which is going to be 6x squared minus 2x, multiplied by the function itself, e 2x cubed minus x squared. That's the easiest derivative ever. So that's the shortcut, so you can always use that as your shortcut for exponential differentiation. For the next differentiation, that's the natural log. But you can see I'm connecting the chain in all of this differentiation. Now, so for the natural log, the derivative of the natural log of x is 1 over x. Let us see how we come to that. Now, so let us have our y as equal to the natural log of what? Of x. What you're going to do, we're going to change it to exponent. So what you're saying here is that e of y is equal to e of natural log of what? Of x. That means e of y is equal to 2x. You can always see it like that. Or some people always get confused with this. Or you can see natural log of x as if I say y is equal to natural log of x, means y is equal to log base e of x. And how do we turn into indices? The base is e, the number or the power is y, equals to what? Equal to x. Base e, power is over here, and this is the number equal to x. That's how you turn it. Or you can look at it from this perspective here. So that means I have e of y equals to x. Remember, I know the derivative of the exponential, so I'm just going to write like this. X equals to e of y. That means I'm going to get the x with respect to what? To y, the x dy, which is going to be e of y. Remember, we are just doing the same thing like we did before, that when we say that if y is equal to e of x, what is dy dx? Dy dx is equal to e of what? To e of x. But now we're just swapping, it just swapped around. So we have e of y equal to x. So x the subject, so that means the x dy equals to that. That means if I'm looking for the dy dx, what am I going to do? I'm just going to flip it. It's going to be 1 over e of y. But what is 1 over e of y? You know, over here, 1 over e of y is that. That means we have our dy dx as 1 over x. That's how we know that the derivative of the natural log is 1 over what? 1 over x. Now, this is something that you should know. It's going to be in your head. Okay, now let us see how do we get the derivative of, say, maybe 2x. Now, here we're going to apply the laws of logarithm. What are the laws of logarithm? Now, when I say multiplication, what comes to my mind, it means that there was addition. That means I'm going to have this as y equals the natural log of 2 plus the natural log of what? Of x. This is a constant. So if I'm looking for the dy dx, this is a constant, this is 0. That means my answer is just the derivative of natural log, which is just 1 over what? 1 over x. That's it, only that. I'm using the laws of logarithm. What about here? Here, so I'm going to use the law of logarithm. This one here is a power of 2. So x power of 2, what's going to happen is that it's going to come down because it's a power. That means I'm going to write this as 2 natural log of what? Of x. So what's my dy dx? My dy dx here is 2 multiplied by the derivative, because this is just a constant, which is, so your derivative here, dy dx is just 2 over x. What about this? It's the same thing we're going to say. If you see a division, it means that it was a subtract. That means this is natural log of 3 minus natural log of what? Of x. That means my dy dx is equal to natural log of this, the derivative of natural log of 3. That's a constant, so the derivative is 0, and the derivative of 1 over x, or derivative of natural log of x, which is equal to 1 over x. That is your derivative. So when you are trying to find the derivative of the natural logs, you are using the laws of indices to simplify your expressions, and then you find the natural log. Now, let us see more examples here. Now, what if we have an example like this? Still, you can see I'm coming back to the chain rule. What if we have examples like this? Now, this is addition. I cannot take it to the laws of, I cannot take it to the laws of logarithm. So what am I going to do? I'm going to look at this in the chain rule perspective. I'm going to say that your u be expressed to. That means your y is equal to natural log of what? Of u. So your du dx is equal to 1. And that means your dy du is equal to 1 over u. 1 over u. That means what you have from the chain rule, dy dx is equal to dy du multiplied by du dx, which is just 1 over u multiplied by 1. So your answer, your derivative is 1 over u, which is 1 over x plus 2. That's your derivative of this function. Let us try it again. Let's find another example here. Let us look at another example here. So you use the same pattern. So you say that our u is equal to 2x cubed minus 3. Minus 3 here. It means that our y is the natural log of u. And then we have our du and y, our du dx as equals to 6x squared. And then our dy du as equal to 1 over u, because the derivative of natural log is what? 1 over u. That means what we have here, our dy dx is equal to dy du multiplied by du dy what? Du dx, which is going to be dy du, which is 1 over u multiplied by du dx, which is 6 what? 6x squared. So your answer here is 6x squared over u, and what's your u? 2x cubed minus 3, like that. I have one more. It is interesting. Now, one more here, what you're going to do, the laws of logarithms, because with 3, I'm going to apply the laws of logarithms first. So you're going to select our y equals to 3 outside, and then I have natural log of x squared minus x. Then what we have here, we have our u as equal to x squared minus x, and then our y as 3 natural log of what? Of u. The derivative of the y du, 3 is a constant, just 3 times what? 1 over what? Over u. And the derivative of u du dx is just 2x minus 1. Now, if you see here, we're just going to multiply the 2. So our dy dx just going to be 2x minus 1 multiplied by the dy du, which is 3 times 1 over what? Over u. So your answer here is 3 into 2x minus 1, all of it over what? Over u, which is x squared minus x. Now, it's time for us to see the shortcut here. You see the shortcut if you consider the chain rule here. You see the shortcut when you consider the chain rule, because this will always work. Now, when you see the answer here, the answer for my derivative is going to be the derivative of the inside, which is 1, over the function itself, which is x plus 2. Shortcut, you see it from here, that if you have this 3 down, and then you have this one inside, 3 just a constant, so just a constant there. And then we have the derivative of the inside, which is 2x minus 1, over the original function, which is x squared minus x. That's your derivative. That means if you have a natural log function, the derivative is always going to be the derivative of the function over the function itself. That's the natural log function. That means, if I can give an example here, if I have y as equal to the natural log of, say, e of x, 2e of x plus x squared. What's the dy dx over here? It looks complicated, but dy dx is very simple. We get the derivative of the inside, so which is the derivative of this one here, which we have just seen, which is 2e of 2x plus the derivative of this, which is 2x, all of it over the function itself, e of 2x plus x squared. All right, that's a derivative. That's your dy dx of any natural log function. We can have more and say if y is maybe natural log of, say, 3x power of 6 plus, say, x squared, what's your derivative here? So your derivative is, say, the derivative of the inside, which is 18 x power 5 plus 2x over the function itself, which is 3x power of 6 plus x what? X squared. Now this formula will always work, Even if you don't remember the rules of logarithm, this formula will always work. Even if you come and try to apply it over here, it will still work. The derivative of the inside, which is 2 over the function itself, which is 2x. You can see it cancels out, and then you come up with 1 over x. It always works. The derivative of the inside, which is 2x, over the function itself, which is x squared, we simplify to 2 over x. It always works. Now this one here, I wouldn't use that. I will just turn it back to this. But still, even if I want to use that, I will see this as 3x power of negative 1. So the derivative of the inside will be negative 3x to the power of negative 2 over the function itself, which is going to be 3x power of negative 1, which is going to be negative 1 over x, like that. Now we have seen the exponential function, the e of x. Now, what about the other exponential functions where the base is known, the e of x? So we type y equals to a to the power of x. We see that our answer is going to be that. That means if y is equal to of x, that means our dy dx for this function is just going to be 2 to the power of x, and then natural log of what? Natural log of 2. But the question is, yes, this is the formula, but how do we reach to that point? That means what you're going to do, you're going to take it back to the natural log. So that means if my y is equal to e to the power of x, what I do, if we take the natural log, that means natural log of y is equal to natural log of 2 power of x. That means natural log of y is equal to x outside, natural log of what? Natural log of 2. Now, to do this, we can make x the subject. we can make x the subject, or we can use implicit differentiation. But since we have not done implicit differentiation, I'm going to look at it as if you're making x the subject. So you have y x is equal to the natural log of y over a natural log of what? Of 2. Natural log of 2. But remember, the natural log of 2 is, this is a constant. So this is just a constant. So just look at it as x is equal to natural log of y. Now get the x dy. The x dy. So the x dy, it means that you are getting the derivative of natural log of y, which is equal to 1 over y. Now all of it over what? All of it over the natural log of what? The natural log of 2, because it's just a constant. That's natural log of 2. That means, what's your dy dx? So you can have your dy dx. Let us have this. So the x dy is equal. How do you simplify this? This is 1 over y, natural log of what? Of 2. That means, what's your dy dx? Your dy dx is equal to, you flip it. So it is y, natural log of what? Of 2. But what's your y? Your y is exactly what you started with. That means your derivative here is 2. Natural log of what? Is 2 power of x, natural log of what? Natural log of 2. That's why this answer comes to be this. But you can always have this formula here, and you remember the formula. You don't have to run through all of this process here, but they can ask you to prove it. All right. What if this is not x, but if something like maybe to the power of 2x, the power 3x? So we don't have to do any working out here. If you have, remember our formula here, so the y dx for this one here is equal to just 3 at power of x times natural log of what? Natural log of 3. We have seen the process. Now, what if we have 3 to the power of 4x? We can see the process here. But our answer is just going to be a to the power of kx, k natural log of. That means the derivative here over dy dx here is just going to be 3 to the power of 4x multiplied by, then you have 4 natural log of what? Natural log of 3. How do we come to this now? If they give me this in an exam and I remember this formula here, I just write my answer. No problem with that. But what if I cannot remember it? I can think about the chain rule in so many different ways. How can we think about it? I can say, let my u equals to 4 what? To 4x. That means my y is 3 to the power of what? Of u. Then I have my du dx as equal to 4. And then I have my dy du, because I know the derivative of this. That means what I'm going to have this as 3 power of u, natural log of what? Natural log of 3. That means when you have your dy dx, what's it going to be? It's going to be the dy du multiplied by du d what? Du dx. So that means you have your answer as the y du. So 3 u natural log of 3 multiplied by du dx, which is what? Which is 4. That's how your answer turns out to be 4 natural log of 3 times 3 power of u, which is 4x. This is how it comes to be that. Now, it is very important for you to remember how to do this, because sometimes this formula can be a little bit confusing if you just put so many formulas in your head. So you can even try this one out and say, all right, we shall let our u equal to 5x plus what? Plus 1. That means our y is 3 to the power of what? Of u. So what do you have over here? So what we have our du dx as equal to just 5. And then our dy du as equal to just 3 power of u, natural log of what? Natural log of 3. Then your dy dx. So my dy dx is going to be dy du multiplied by du dx. So when I multiply here, I have dy du, which is this 3 power of u, natural log of 3, multiplied by dy dx, du dx, which is equal to 5. So that means my answer just 3 power of 5x plus 1 multiplied by a natural log of 3 times what? Times 5, like that. So still we are connecting the chain rule. This is exponential, the derivative of exponential of functions. All right, so you can see the formula that you need to remember here is this formula here. This is what you need to remember, and then you can apply it to this function, this type of function, y is equal to a of x. And for this one here, even if you don't have it in your head, you can always use the chain rule to come up with any derivative you are looking for. Thank you.